Lesson 4.5, Congruence in Right Triangles. This lesson starts out by saying Seth and Jay wrote the following explanation of why the two triangles are congruent. So look at these two triangles. This 5, the hypotenuse. There's a 4 of one of the sides or the legs, and then there's a right triangle. Seth, there are two pairs of congruent sides. So the 5s and the 4s. And a pair of congruent right angles. Therefore, they should be congruent by side-side angle. Now think of all the rules we've learned before. Is side-side angle an actual rule that proves triangles are congruent? Jay says the length BC and EF are 3. Now, there's no indication that there's 3, but if you use the Pythagorean theorem, a squared plus b squared equals c squared, and solve for that b squared, you will get 3. So that is a true statement if you use the Pythagorean theorem. There are 3 pairs of congruent sides, therefore they're congruent by side, side, side. Is that one of the rules that we've gone over? You need to determine which one of these rules is a legitimate rule. There's only one. And then you can decide whether these triangles are congruent and explain it here or in your workbook. Here's the next problem, and it's just part B. So to communicate precisely and describe when you can state that two right triangles are congruent. So when is it okay that a right triangle actually uses a rule that proves congruence? And you can think of a couple examples, hopefully. Example 1, investigate. So we've got these two right triangles. It says when any two pairs of corresponding sides are congruent. So any two pairs, so like let's say FE and CB, if that's one pair, then another pair. So if two pairs of corresponding sides are congruent, can you show that two right triangles would be congruent? So can you show that? And it goes through step by step. So let's go through this. So here's a visual. If it says CB and FE, there's one pair, and then ACDF, there's another pair. So you've got that side, that right angle, then the other side. So those would be congruent by side angle side. That's one example. Here's the next example. You have the hypotenuse and then this other leg and the angle. Now, there is not a rule that is SSA. Now, if I spelled that backwards, be careful. ASS, that is not appropriate for math. It is not a math rule, no matter which way you spell it forward, ASS or SSA. Either way, it is not a rule, not allowed at all. So this is not allowed, but if I figure out by using the Pythagorean theorem, and you figured out that, hey, these would be the same, because a squared, b squared would be what you're trying to find, c squared is the same, that b squared would be the same number, even if we're not even using numbers, that same length would be the same. So you could figure it out by side, 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 if you're using the Pythagorean theorem. So as a result, this rule where it's ASS, that doesn't work. It works only on right triangles because of the hypotenuse and the leg and the Pythagorean theorem. And there's a rule specifically for that, so you don't have to use that inappropriate word. So we'll go over what that rule is. So it says, can you show that two right triangles are congruent when one pair of corresponding acute angles is congruent to one pair of the corresponding leg? So I'm going to kind of show this to you. I'm going to draw this out. I'm going to put this on a different screen here. So if I've got a right triangle, and I have another right triangle, and I'm trying to show that those are congruent. That doesn't look super right, but I'm going to mark it. So those are supposed to be right. And it says you have one corresponding leg, congruent, and then one acute angle. So if I took this angle, let's say, those two angles, I'm hoping you can see that those would be congruent by angle, side, angle. And you're like, okay, not too bad. But if I had another set, so I'm going to draw other triangles, and I'm trying to show that these are congruent. Okay, so still have that acute angle, but it says any leg. So could it be this leg over here? Well, let's check. Is there a rule? Let's see, I have a side and two angles in a row. Two angles in a row and a side. Hey, that's angle, angle, side. And remember, it doesn't matter. You can spell it backwards. It's still the same rule. Okay, so this does work. Check, those work. All right, here is the actual rule. The rule that I mentioned, that ASS or SSA, that you cannot use and not appropriate, but only works on right triangles, we actually call it hypotenuse leg because we don't want to use ASS. We want to use hypotenuse. It has to be the hypotenuse, and it has to be one of the legs, and it must be a right triangle. So this is what I recommend. If you see triangles that are right triangles and you're trying to prove that they're congruent, as soon as you see that right angle, check if HL works. If HL doesn't work, there's no hypotenuse or leg that are marked, then you just move on to like side angle side or side or any of the other rules that we went over. It has to be corresponding hypotenuse and corresponding legs. Here, let's use this theorem. Here it is. It says Ashton is washing windows, and so there's this little right triangle right here. Notice it's a right triangle, and he has a 10-foot ladder. So that hypotenuse is not changing. The ladder length is not going to change. So it says, how can you determine where to place the ladder to be sure it reaches the last window? So this height, straight up and down, has to be the same as this height right here. Okay, so that means it's a right triangle. The hypotenuse is not changing, and we want that height to the window not to change as well. We need to show that AH is congruent to BK, so that height is congruent. And they do that by using the HL, hypotenuse, and then AH, BK, that's the height to the window. Those would also be congruent. And we could create congruent triangles, which means I'm not measuring straight up from AH to BK because that's the height of the window. That's already like a set measurement. What you're figuring out is from RH, that distance needs to be the same as SK. So the distance he puts the ladder away from the wall needs to be the same over here as well. Let's try it. What information is needed in order to apply HL? So you have that this hypotenuse is 9. You don't have anything here. You have that this leg is 5, but you don't have anything measured or marked on this triangle. But you do know they're both right triangles. So you need to say basically what's missing or what else do you need to prove those triangles are congruent by HL. Writing a proof. These proofs are kind of long, but that's okay. We'll go through them. And when I go through these, hopefully you can see them. And I might write on this visual to help you see a little bit better. So FDAB. FDAB. Notice that right angle. That symbol means perpendicular, which means it's a right angle, which hopefully means you understand they would be congruent. Other right angles would be congruent. They're both 90. Hey, look, there's another perpendicular. So FE and AC, those are perpendicular. So those are creating both 90-degree angles, which would both be the same. That would be great. And then AE, so notice all these tick marks. AD, tick mark. FC, FB. So I'm just going through making sure you understand all the pieces. So let's look at what they actually have for the proof. Most proofs start with a given, which this one does. But notice it only starts with part of the given, so the perpendicular. Well, we know they're perpendicular, so that means those angles will be congruent, and they will both be 90. Oh, they're congruent, and they're both 90 because of the definition of perpendicular. Okay, now at this point, you could go different ways of this proof, but let's see which way they go. Let's see. Definition of a right triangle. Hey, if there's a triangle with a 90-degree angle, it's going to be a right triangle. Now, if you look at both sides, if this is 90, this other side is 90. In some proofs, they might say that. They might say that angle FEC is also 90, and FDB over here is also 90 because of a linear pair or angles on a line. But this one doesn't, and that's okay. So definition of right triangle. If there's a triangle with a right angle, it is a right triangle. So we can do that. Okay, this is given. So they just threw some more given in there. And then they talked about the reflexive property. Reflexive property is saying that something is equal to itself. AF is congruent to itself because those are there. That one side in the middle is shared on both triangles. So it needs to be, this line needs to be congruent on this triangle and it needs to be congruent on this other triangle, which it is. It's the same as itself. So that's the reflexive property. And then because we know that this is congruent to itself, that's the hypotenuse. We know that there's a leg. We can say, hey, HL, it has the hypotenuse, it has the leg. Those two triangles are congruent. But we're talking about ABC, this entire triangle. We need to prove that it's isosceles. So we need to keep going because we're not done. We just talked about these two triangles up there. So I'm going to switch and go down here a little bit more. CPCTC, that means once triangles are congruent, which they are. These triangles are congruent by HL. I need to show that some side lengths or angles are congruent. So EF is the same as DF. Well, if they're congruent triangles, then I'm going to put 3 marks here if I can, squeeze them in there. Then the side lengths are congruent. So because those two triangles are congruent, those side lengths are congruent. Now look at these two triangles down here. It's starting to help. Remember, this is a 90. This is a 90, and I'm like, hey, I've got two right triangles. I've got the hypotenuse marked, and I've got another leg marked. So let's see what they do. Oh, they talk about this. It's already given. We had already talked about that earlier, those two tick marks. And yep, they did it. HL. Oh, it slid down. Let me go back to this. There's all the marks. These two triangles are congruent because of HL. So if those two triangles are congruent and the top two triangles are congruent, this whole huge triangle, those two on both sides, we can say that. Let's see what they say. And I know it's going to mess up my drawings, but that's okay. It says these angles ACF, ECF, and DBF. So let's see where those are. Right here. So let me clear out all this mess. And I need to show you that this angle right here is congruent to that angle right there. And remember, we're proving that this huge triangle is an isosceles triangle. And I know base angles are congruent right now, those two base angles. Remember, we did that rule a while back. So let's slide down. The converse. If we know those angles are congruent, then we know by the converse of isosceles triangle, these side lengths are congruent. Let me mark them. This whole side length and this whole side length, those two are congruent to each other. And I'm going to put double marks because that single mark was just going from A to D and A to E. So those are definitely creating two congruent sides, which means that is an isosceles triangle. So I'm going to go down here, and sure enough, look at this last step. That is an isosceles by definition of isosceles. Now, as you visualize this, this is a multi-step complex proof. It proved that one set of triangles are congruent, it proved that another set of triangles are congruent, and then it proved that together it's isosceles. At this point in your math, you might not be ready for this proof, but hopefully you're ready for parts of this proof, maybe like the first part, or the second part, or the third. So, but that's a complex proof. All right, we have this. It talks about perpendicularity and congruence, and I need to prove that these triangles are congruent. So let's go to my whiteboard. I've got it all written out. It's not as pretty, but you get the idea. I started with my statements. So the given, I'm going to say step 1, given. Now, the proof, as far as the answers are concerned on the interactive text, your proof could be in a totally different order than mine. The proof in the interactive textbook could be in a totally different order than mine. I'm just doing it in an order that makes sense to me. You do the same. So whatever comes to you first. A lot of people might start with just this first given about things being perpendicular and then work off that. I'm putting all the given there first. So it's totally up to you. There is more than one right way to make this proof. All right, so I've got this. JL is perpendicular to KM. So all 4 of these right here are right angles. How do I know that? Because of perpendicular. So I'm going to say step 2. Angle JNK is congruent to angle LNK, which is congruent to angle L and M, which is also congruent to, you're getting the idea, of M and J, and all of those equal 90 degrees. Now you can write it in a couple different ways. You can do each one a separate line, that's fine. But the bottom line is, I know that because of the definition of perpendicular. Definition of, and you can just write the perpendicular symbol, or you could write out the word perpendicular or perpendicularity. So by the definition of perpendicular, I know that all of these angles are congruent and they all equal 90 degrees. Okay, well, so what? What's next? Look at what's given. I know that JK is congruent to LK. So JK, LK. So I've got that. Now, we are trying to prove, and I'm going to put this in a different color, we are trying to prove that this entire triangle is congruent to this entire triangle. So the left whole side and the right whole side. Well, for beginners, we need to start somewhere. So I'm going to start with these top two triangles that we're working with right now. Those two orange triangles. I know that they're right angles. I know that they both have a hypotenuse that is congruent. And I know that they are sharing a side. That is going to be a key thing to our proof. I'm going to say, hey, these are sharing a side. There's a rule for that. When they share a side or share an angle, you can use the reflexive property. So I'm going to say Kn is congruent to Kn by the reflexive property. Okay, those are congruent. Now, look at those two triangles that I did in orange. I've got a right triangle, a hypotenuse, and a leg. You should be able to say something about those two orange triangles. You should be able to say that those two orange triangles are congruent. And I'll write the step in orange just so you know that those are the orange triangles. So step 4, triangle. JNK is congruent to triangle, and I know you can't see it yet, LNK. So those are the two triangles. They are congruent because they had a hypotenuse and a leg, and they're both right, HL. So they are congruent because of HL. Now, if they are congruent, the whole triangles, then we should know the pieces of those triangles are congruent. So I'm going to go back to that visual. I'm going to hope you can see this out. If I mark this in a darker blue, or I'll use a lighter blue, right here, and right here, since these two orange triangles are the same, they're congruent, we already proved it, then wouldn't these two sides be the same? Okay, and there is a rule, like once you prove the triangles are congruent, you prove that the parts are. Hopefully you can remember that rule. But I'm going to say step 5, JN is congruent to LN. It's lots of capital letters. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Or you could just write out, once the triangles are congruent, then the side lengths would be congruent. Okay, that's okay too. So I just proved those sides are congruent. I know this is a right triangle. Now we're going to add those orange triangles. We're going to make them even bigger. Or I'll use a different color. We're going to add to these triangles. I know that this side is the same. And I know this right here, this is a red. I don't know if you can tell. This side right here, if I was just talking about these two triangles, this side is shared between the two of them. We've already used a rule like that when they share a side. It's the reflexive property. So I'm going to say that MN is the same as itself. So MN is congruent to MN, next MS, reflexive property. Okay, this is a long proof. This is a lot to be involved. But I go back to that picture, and I know that line in the middle is the same. I know these top two sides are the same, and I know it's a right triangle. So let's look at that. Here we go. I'm looking up at this. I've got a side. I've got these right triangles, and I got these sides congruent. I do not know anything about the hypotenuse. The second you see a right triangle, you think, oh, HL. But I don't know anything about the H, that hypotenuse. Therefore, HL is off the table. Oops, I just erased that. So I need to use a different rule. So I know this is congruent to itself. I know that these are congruent. I know that angle, sorry. So I've got a side, an angle, and a side. Those are congruent. So I'm going to say step 7, triangle MNJ is congruent to triangle MNL. Side, angle, side. And even though it's a right triangle, you don't have to use HL. You could use a different rule. In this case, side, angle, side. We are getting so close. We need to prove that the triangles are congruent. The huge triangles, those big green triangles. So JKM, this whole thing, and this whole thing. We know these are congruent. We know that this K to M is congruent because of the reflexive. We said each part. We said KN is congruent because of reflexive. We said MN is congruent to itself because of reflexive. We might need to say that they're the whole thing. Some people might require it. Some teachers might not, but we'll say it just in case. So we know these two sides. We know this middle side. And then we just have to show somehow that these are congruent. But we already proved that these triangles are congruent. Therefore, these sides are congruent. So I'm going to mark them. But I need to state why. So I go down here and say step 8. See how long this is? JM is congruent to LM. Once the triangles are congruent, the parts are CPCTC. And then just to be careful, and I'm not sure about your teacher, I'm going to put step 9 as KM is congruent to KM. That one straight down the middle. It is definitely congruent to itself. So I'm going to add that by the reflexive. Trying to move this out of the way. There. And I have everything I need. I have sides, and I'm going to put a little S over here. So I know that these sides, this whole side of the triangle is done. I know that JM and LM, so I'm like, hey, that's another set of a side. And I already know that JK and LK are the same. And I said that somewhere. I got to find it. JK, LK. That was given. So look at this. I have a side. I have a side, and I have another side. So sometimes when you're writing a proof and you're like, I'm not even sure why they're congruent, you go back up into all the steps and figure out what's labeled. I could talk about the angles. I could talk about the sides. But in this case, I found 3 sides corresponding with 3 other sides that are congruent. So I'm going to say step 10. Triangle JKM, that's the huge big triangles on both sides, is congruent to triangle LKM. Side, side, side. That's a 10-step proof. That's probably the longest proof we've ever done. This one and the previous one are really long. Now, when I go back to this problem, I noticed when I was checking some of the answers, some of the lettering I didn't think was right. I think they mislabeled this N. And I can't remember exactly, but let me just quickly type in something, and I'm going to check the answers. So this angle, definition of perpendicular, see how it says JKN? The right angle actually should be N, should be the middle letter in there. Okay, so some of those I noticed are incorrect, so be careful. You can use my example of the proof, the step-by-steps. This proof, I think, is correct, but the way they labeled them is a little bit different, and they used side, angle, side. So I did it in a totally different way, and both of these are correct, assuming that they fixed their lettering, but both of these ways are correct and different. So there's more than one way to prove triangles are congruent, which is kind of nice and kind of tricky at the same time, so be careful. Okay, big picture. This is the whole lesson. Let me put this out of the way. There are 4 rules that are given right here, but there are 5 rules that we will have finished at the end of this lesson. So we've done side, angle, side, angle, side, angle angle side, and then HL. Those are the 4 this lesson goes over. But the proof that I just did went over that 5th one, and that's side, side, side. So there are 5 rules to help you prove triangles are congruent. Here are 4 of them. I hope this helps.